आधा काम मिलेगा और
Hello, Assalamu alaikum.
ये आपका पॉइंटर है सर। अच्छा अच्छा अच्छा, ये यहाँ भी पड़ा हुआ है। ठीक है ठीक है। ठीक है। औज़ुबिल्लाहि मिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम वल अस्र इन्नल इंसाना लफ़ी खुस्र इल्लल लज़ीना आमनू व अमिलुस्सॉलिहात व तवासौ बिल हक़्क़ व तवासौ बिस सब्र। On behalf of Pakistan Society of Civil Engineers, I welcome all of you and a very warm welcome to our audience on Facebook and YouTube. And very special thanks to our audience on Facebook, especially from USA, who must be at a very odd time now. And same is true for the audience from Australia. Thank you very much, sir. Before I introduce to you our guest speaker, just a brief introduction of Pakistan Society of Civil Engineers, as I can see some new faces here. So Pakistan Society of Civil Engineers got the license to operate on 5th May 2016. It was incorporated on 7th June 2016. And we made our inauguration on 3rd January 2019. This span of 3 years was just because of some reasons, unavoidable reasons, and delay did take place, but finally, eventually, we started and we had a good start. Ajay ji, aage aa jaye, please. Now the society is very much functional. We have today is our 7th event, a technical lecture, and the guest speakers has been always a new person in every event, and Pakistan PSC is trying to bring for you new topics for the lecture, and inshallah we will continue to do it. Membership to date, I think we have around 60, but student membership is still very less. I would again request the students, if at present here, please become the member of Pakistan Society of Civil Engineers. The fees is not very high. It is only 250 rupees, 250 per annum, and that would be just to cater for few expenses which society has to incur. We are not earning any profit of the fee. Whatever the fee is coming to the society, it is being spent on seminars and some other activities which we are going to start. And the society has its quarterly magazine, fortnightly newsletter. Please visit the society's website. All these documents are available there for your reading. Now, since we are already late, I will just introduce the speaker, and then I'll give the floor to him. Our today's speaker is Dr. Fawad Muzaffar. He did his undergrads from UET. Undergrad means BSc Civil Engineering from UET in UET Lahore in 2000. He worked as a site engineer for a year before he joined NESPAC in 2001. There he was involved in the designing of transportation structures like Islamabad Murray dual carriage way, and he designed some pre-stressed bridges on N70 highway, and there are some other projects also which he had worked on when he was in NESPAC. Then in 2004, he proceeded to California, and he did his PhD from there, from Stanford University. Dr. Saab, I don't know, when did you complete your PhD?
2012.
2012, yeah. Then, and currently, Dr. Saab is working with IDAB, which is Infrastructure Development Authority of Punjab. And mashallah ji, he has worked on a lot of projects like High Q Tower, City Shopping Wall, Sky Park, Pakistan Kidney and Liver Institute, Tayyib Erdogan Hospital, Information Technology University, Orient Towers. So mashallah, he is very experienced. And today's lecture's topic is design of buildings, the state of practice in Pakistan versus the state of art. Basically, it is the practice which is being followed in Pakistan. He is going to compare what is done outside Pakistan. What is the state of art outside in America or in Europe? That is the basic theme of his lecture. And inshallah, I'm pretty sure that you will enjoy the lecture. It will be very much technically beneficial to you. So, Dr. Saab, please proceed to the podium, and the floor is yours. Thank you.
Thank you, Dar Saab. Sorry.
Thank you.
Okay. It's a pleasure to use this forum and to address one of the topics that is very near and dear to me. As you know, recently there have been a lot of changes, and there has been a drive to go up rather than spread horizontally. So these sort of topics become more and more relevant. So without any additional due, let me proceed with the topic. I'll start by introducing the convention the convention that is followed in Pakistan to design a building. So we start off with preliminary investigations, and preliminary investigations are primarily of two types: topographic survey and geotechnical investigations, right? So this is the information that you have before you start to construct a building, typically. Now, topographic survey is basically used to decide your levels and whether you should have an elevated ground floor level, or you want to elevate the site, you want to have a grading plan or something like that, right? And geotechnical investigation is obviously it tells you about the type of foundation that you're going to have. Now, it's not as simple as that, because sometimes the geotechnical investigation tells you informs you about the site in a certain way that you might end up saving money by adding a basement, right? Because if your soil is weak, you might spend a lot of money going for the piles, but if you add an additional basement, that will result in additional covered area for the owner, and it will save a lot of cost in terms of piles. So this step seems basically primarily done to select the type of foundation, but it is not as simple as that. So after you're done with the geotechnical investigation and the topographic survey, the first thing that you have, or the way I think about it is, we know about the space utility plan of the building from the architect, right? And so we can therefore, we know about the spans, we know about the typical live loading and dead loading and everything. So we tend to think about the flooring system that we will adopt for design of the building. After that, the next step is you tend to start to think about your lateral force resisting system. And Rizwan sir, please correct me if I'm missing a step here or not. There are a number of options given in the UBC code, right? So you have this building frame system, and then there are the shear walls, then there is a bearing wall system, then there is shear wall, then there are dual systems up here. And so a typical structural engineer would go and would pick one of the lateral force resisting systems. Now, the consideration here is, you would like to pick a lateral force resisting system that is the most economical, number one, and number two, that is permissible by the code, right? So not all types of lateral force resisting systems are permissible. Not all permutations and combinations of the lateral force resisting systems are permissible. So after you've done that, you select and you specify the gravity loads, and you thought about these gravity loads when you were selecting the flooring system, but then you specify the gravity loads on your computer model. You develop a computer model, right? And after you've done with the gravity loads, the next step is you go and select, you go and specify your seismic loads. And for us in Pakistan, we have this map, the very standard map that is in front of you. It has I would say 5 zones, right? Zone 1, Lahore is zone 2A, zone 2B, zone 3, and zone 4. All right. So we pick one of the zones up, and then we go and we use this equation to calculate the minimum base shear, right? And then use this equation to estimate the time period of your structure. And one of the common mistakes people do with this equation is the H term is not that straightforward always. Imagine you have a building that is on a hillside, right? Whether you will use H as the largest value of H or the smallest value of H. So this is not that straightforward, right, to use. Then you go to the tables and you select the zone. You select the Z value. For Lahore, it's 0.15. You select the soil type that you have, the information for which you have available from the geotechnical investigations, and you pick this number up, right? Magically, the 0.2 For Lahore, it's 0.32, right? And then you pick those coefficients up. Now, what is CA? CA is basically your PGA, right? Peak ground acceleration. Because for a zero time period, this is what CA is, right? So CA, you pick the CA up. You basically you're using this information to pick your PGA from the UBC. Now, then you consider the effect of your building geometry, whether it has irregularities or not. And if it has irregularities, you go into the tables and you see whether it's torsional irregularity or vertical irregularity or horizontal irregularity. And then you pick, you decide whether you will use the amplification factor or not, right? Then you develop a computer model, apply all of those live loads. It's very easy in ETABS. You go and construct an response spectrum, specify 100%, 30% rule if your building is irregular. Otherwise, you don't have to even bother with that, right? And then you undertake linear elastic analysis of the computer model. Now imagine, this is very popular. This whole scheme of things is very popular in Pakistan. The reason being, a kid can get out of a school, have zero experience, and follow this cookbook and design a structure, right? Things seem to be very easy. So it's the method of choice in Pakistan. You don't have to have any specialized knowledge of structural engineering, or you don't have to have any understanding of seismic hazard risk of various regions. And you just follow the scheme and you get it done. Then I missed something, that stability checks, which basically is you would check whether you have a failure in one of the columns or not, something like that, and then you design all of the schemes, all of your members. Right? So after you've done with the design of the superstructure, you have the geotechnical information, and typically, a structural engineer would know before he starts as to whether he would go for a raft or a spread footing or a isolated footing. But this design of foundations come typically later, after you've designed the superstructure. And I might be wrong, so please feel free to correct me. But this is the practice that typically is undertaken in Pakistan, right? And then you develop a computer model in SAFE, right? That computer model is not connected to the superstructure. So what you do is, ETABS allows you to export all of your forces at the base level, bring it to another software called SAFE. You apply those forces to the SAFE model, and then the deformations sort of are never transferred back to the superstructure. Have you ever thought about it? Because we have been following this practice. And then there are stability checks. You see whether there's a punching shear failure or not, whether you need to thicken the pads or not, and then you would design the foundations. So as the performance-based literature would say, this is a perfect cookbook. Here are a few pointers that I would like you to think about. You are designing for reinforcement, right? But up to this point, whether you have designed the superstructure or the foundations, did you ever consider stiffness of a column, for example, with 4% axial flexure reinforcement as compared to stiffness of a column with 1% axial flexure stiffness? No, right? It's very easily conveniently estimated as BH cube over 12 multiplied by the crack stiffness modulus that is given in the building code of Pakistan. And I was, when I thought about it, I was amazed. You know, here we are, the core purpose of any concrete structural design are two: to proportion the size of the elements and to decide about the reinforcement within the elements. The reinforcement is one of the most, fundamental parameters of reinforced concrete structures, but yet we never, account for those reinforcements when we are proportioning stiffnesses in our finite element model. It's amazing, right? Anyways, so here we are done, we get the project done, and we just push it, and we get the money, and that's the state of the practice in Pakistan. Very popular. All you need to do is you need to know how to construct the response spectrum. You need to know which button to press in ETABS. Anybody can do it. So let me now take you on a very small journey. We'll start off with some preliminary theory, and then I'll take you very abruptly into the practice, but very briefly, because I don't have the time, right? These kind of things would require you to have lectures, right? So I'll go through it very briefly, and you might find my intention is to give you a flavor of things, right? So let me start off with theory first. We have heard about the moment magnitude, right? There is a Richter magnitude, then there is moment magnitude. Just to give you an idea of the relative size of events. When we hear about magnitude 6, magnitude 5 is probably the threshold which starts causing damage to the buildings. Below magnitude 5, we are not interested as engineers, because that doesn't result in much damage to the building. Magnitude 6, magnitude 7, magnitude 8, magnitude 9. It's huge difference between the amount. This is, and by the way, all of these circles represent the amount of energy released. So don't be deceived by magnitude 7 से 8 के दरमियान जो the difference between the two. It might seem as the difference is linear between 6 and 7 and 7 and 8, but no. The amount of energy that is released in such events is not linearly varying, to say the least, right? Number one. Number two is many countries in the world, many countries in the West, including the US, what they have done is they have installed an array of seismometers. And I'll just show you the animation of one of the events that was recorded by the array of these seismometers. So this is an event that was that occurred at Peru-Brazil border region, and you can see the waves passing through. And this accelerogram is, by the way, recorded at this station. All right. So you can see the waves passing through the Earth crust as one of those events unfolded, right? Now, I want you to keep this. I want you to keep this set of array, this array of seismometers in mind for further discussion. So what they did in the US, especially in California, was they said, okay, we have these hundreds of seismometers installed, and we have hundreds of events that have unfolded since, let's say, 1950s, 1960s. So they had recordings of the hundreds of events since 1960s. So, okay, wait a minute. Can we do something about, predicting the the intensity of the ground motion measure. And I didn't use PGA. I intentionally used intensity ground motion measure. It can be anything. And what they did was, they said, we don't know much about we don't know anything else about these events, but we have one set of information. We have, I'm trying to get this, we have, at each of those locations, we have a relationship between the peak ground measure. It can be PGA, peak ground acceleration, it can be peak ground velocity, it can be peak ground displacement, it can be anything. They said, okay, we have hundreds of these measurements. At each of those locations, we have measurement of each of those events, and let us then plot, the intensity measure, the peak intensity measure, as a function of the distance. So when they did that, they found out that that the scatter looks something like this. There was a lot of scatter, right? But one thing was very evident. As the distance increases from the source, there is a trend, there's a downward trend for the intensity that was either PGA or PGV or PGD, right? And yes, there's a lot of scatter, but what if we draw an average line, an SRSS, a mean square of squares line? We will get a line something like this, right? And then at each of those abscissa values, they quantified the variance around that line. And that turned out to be a normal distribution, right? So these sort of relationships are called attenuation functions. Now, an attenuation function is nothing but a statistical equation giving you a relationship between distance, average, distance from the source to your recording station, and quantifying your ground motion parameter of interest, peak ground acceleration, peak ground velocity, and peak ground displacements. All right. So you have to keep this. This is fundamental to whatever I am going to talk to you about. Attenuation functions, right? So how are these attenuation functions then useful? Well, now I'll not go into the probability theory, but what they did was, they said, okay, now we have an idea of how our peak ground parameter of interest varies as a function of distance, right? So how about if we want to calculate the probability of exceedance of that parameter of interest, and I'll use PGA because PGA is mostly used, then how can we do that? By the way, let me take you back to this slide because it's really important. What this slide tells me is that if I have a distance from the site equal to this value, then there is a mean that exists for a certain PGA value or parameter of ground parameter of interest, right? I can then, what this means is there's a 50% probability that my parameter of interest will be exceeded above this value if I use this value, right? Because I am at the mean. So how about if I say, so 50% is too much, by the way. That means there is a 50-50 chance that if I use this value of acceleration, it will be exceeded. So they said, okay, no, let's do this. Let's, take the 84th percentile, which will be a curve that exists over there, right? Let's take 84th percentile as the value at which we agree that there is a 16% chance that our probability of the peak ground acceleration will be exceeded. That is what they adopted, right? So with this mechanism, we have now a relationship between distance and probability of exceedance of a certain PGA. There are two types of seismic hazards that are carried out in the world. The first type is called deterministic seismic hazard analysis. Imagine we have a site. This is a project site, right? There can be all sorts of seismic sources. There can be point seismic sources. Point seismic sources are volcanoes. One example of point seismic sources is volcanoes, right? There can be line seismic sources. These are fault lines that we have. And there can be area seismic sources. These are the regions which we don't understand. So subduction zones, for example, when one plate is moving under the other plate, we don't know whether the earthquake will be generated due to rupture at this location, or because the plate is dipping at an angle or X kilometers away from this location. So those are examples of area sources. So we can have all sorts of sources, right? Now, if we have that information, if we have identified all of the sources, identification and characterization of all sources, the next step is what magnitude of earthquake to expect from this source. We go to geological catalogs and we find out what they found out was each source cannot generate an earthquake greater than a certain magnitude. So with that information, we can then, we can say that we have completely characterized the source. And by the way, this is a very simplistic, there will be depth, there will be hypocenter, a lot of discussion that I am skipping right now. Once I have done that, the next step is, if I can find out the shortest distance between the source and my project site. Remember this little thing that we developed? I have a probability. I can say that my probability of a PGA value exceeding due to my first source, due to my first source and second source and third source can be plotted like that, right? From here. Because the distance of my site from all of those sources is different, I will have to move, for example, R1 corresponds to this source, R2 corresponds to that source, R3 corresponds to this source, right? And then I will identify, all of a sudden I'll identify that my controlling earthquake comes from my third source, which is this guy over here, right? And not from this source and that source. Very simple. So with that information, I'll have completely solved or completely known. I'll know my threat from a particular. I will know my threat at a particular site completely. I've quantified it. This, this process is called deterministic seismic hazard analysis. Now, it seems very simple. It is very simple. This type of approach was initially used to characterize seismic hazard since decades, until they started to realize that we are only considering the worst possible scenario. What do I mean by that? Well, the earthquake, can occur. Remember, we only considered the shortest distance from the source to the site. The earthquake will not always occur here. The earthquake can occur here. The earthquake can occur over here. Can initiate over here. The hypercenter or hypocenter will be situated. Can be situated here, or for this area source, it can be situated anywhere inside the rectangular region, right? So I am considering the worst possible scenario here. That is what they mean by it does not. So first of all, it does not explicitly deal with uncertainty. I have not, I have just said that this earth source can generate an earthquake of magnitude X, and I have considered the maximum value. What is the probability of that source generating lesser magnitude of earthquake? I have not answered that question. I did not consider that. Similarly, I have only considered the shortest distance, right? So this is what they mean by I have considered the possibility, the worst possible possibility, but I have not considered the likelihood. This is very significant. For example, there are regions in the world, and I'm sure Lahore is one of them, where significant earthquakes occur with the return period that is considerably longer as compared to earthquakes that occur in Islamabad. There, significant earthquakes occur at a shorter return time period. So what does that mean? If I am I'm constructing a building in Lahore, would I construct it like I am constructing it in Islamabad? Everybody knows that significant events are much more likely to happen in Islamabad than in Lahore. But because I was using this approach, where I was using the worst possible scenario, my building in Lahore will be as reinforced as my building in Islamabad, and that is wrong. That is where they realized that this approach has some drawbacks. So what did they do? They started to, this technique was pioneered by, amongst others, by Alan Cornell of Stanford. In 1970s, they started to look at, let's consider all of the variability, right? And what they did was, the first question is, where will the earthquake occur? As I said, it can occur anywhere along the fault lines or within the area source. So the first question is, where will the earthquake occur? How big will the earthquake be? Right? And even if we know where will the earthquake will occur and what is the magnitude of the earthquake, what will be the intensity of the ground motion due to that event at my site location? Right? And the last but not the least is, when will my earthquake occur? These 4 types of uncertainties completely characterize my problem. And so they started to ask this. This is just a slide, and I'll skip this because I've already explained what your point source is. Your point sources are volcanoes. One example, right? There are other point sources. And then there are line sources, and then there are area sources. We've already discussed this. So very quickly, what they did was they said, okay, let's develop probability distribution functions for each one of those types, right? A probability distribution function is basically when you add the area under the probability distribution function, it should end up, you should get 1. And if you look at the probability distribution function, it will give you the probability of a certain ordinate as a function of the abscissa, right? I assume that everybody is aware of PDFs. So, for a site, for a point source, the probability that the event will occur at the source is 1. So whatever the ordinate multiplied by the abscissa should be equal to 1, right? For a line source, they said, okay, we don't know much about faults. They can rupture at any location. So let's assume that the event, the hypercenter of the event, or the hypocenter of the event, would be at one of those locations with equal probability. So there is equal probability that that the event will be triggered here, 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 or there, right? And therefore, the PDF is very simple. You just, from here to here, from R to R main, there is no probability of the event occurring. And then from here to there, you distribute this line into equal lengths, and basically you develop this PDF, because the probability of the event occurring at any of those locations is equal, right? So basically, I take it for granted that you can construct this. And similarly for area, we divide the area into grids, and we assume that within those grids there is an equal probability of the hypercenter existing. Okay. So this is the PDF of area sources. Typically, this is the PDF of line sources, and this is the PDF of point sources. The next question is how big the earthquake will be. And here we had help from a number of geologists. There are a number of approaches, and there are types of faults. There's that exhibit a characteristic slip rate and makes our life easier. Because, for example, this was developed by someone, and I've forgotten to put the name here. By the way, all of this is, I need to issue a disclaimer, because all of this was taken from a textbook in Kramer, or I forgot, and I should have given you all of the references, right? I will give the references. I hope you guys will post it later on. So basically what this is, this was developed as a means to evaluate the probability as a function of magnitude. So if the magnitude of slip rate is 10 centimeters per year, right? Then I can use this band, and I can basically say that my probability that my magnitude 7 will occur is 10, right? And 10 is basically the return period. And I hope you guys are very familiar with the return period, right? Return period is the duration after which, on average, we expect the event to reoccur. Okay? Are we okay? Okay. So we can have all those different types of slip ends, and if there is a slip rate that exists in somewhere in between, we will interpolate and we will get the return period for a certain magnitude of earthquake. This type of relationship is very popular for strike slip faults, right? Strike slip faults are faults that basically slide past each other. And then this is very big. Now there is another way to characterize the magnitude versus the probability. By the way, lambda m is the mean annual rate of exceedance. This is 1 over t, 1 over the return period, right? What they found out was, from any particular fault, if they have a recording for example 80 years, and if they add up magnitude, if they calculate the number of events that are greater than 6, they'll get a certain number. Then if they add up all of the events that have a magnitude greater than 7, they get another number. And if they continue to do it for all of the magnitude, they basically can fit a line through it. This type of relationship is called Gutenberg-Richter Recurrence Law, right? And this is basically fundamentally used for all types of faults in the world, right? And then there are certain variants. Then they realize that this line is basically linear, but there is no data beyond this point, so they had to taper it off. Basically, what they're saying is you cannot have a magnitude 1 event greater than 1,000 or 10,000 events. So basically, they introduced later modifications where they tapered this off. And if you look at this curve, this goes beyond magnitude 10. What they found out is typically faults cannot generate more than a certain magnitude. And this is what they have acknowledged over here, right? So this is called modified Gutenberg-Richter law. So now I have introduced to you two tools. One, we have addressed spatial uncertainty. Remember this slide? I have, very briefly and addressed how to address spatial uncertainty, and we have also addressed how big the earthquake will be using Gutenberg-Richter or modified Gutenberg-Richter. The next thing is the intensity of ground motion. I have already introduced the attenuation functions for you guys. So we have all of the probabilities individually worked out, but we have not been able to integrate all of the individual probabilities, and I'll show you how we can do that. Before I go into this, and this is the magic of it, we use a theorem of mathematics to stitch all of the individual probabilities. And that theorem is called total probability theorem. Imagine if you have a factory, right? And the factory produces, imagine you have 4 factories producing light bulbs. Factory 1 produces light bulbs and its market share is 15%. And the probability that its light bulbs will continue to work after 5,000 hours is 99%. Then we have a factory 2, which has a market share of 25%, and the probability that its light bulb will continue to work after 5,000 is 95%. And similarly, we have a factory number 3 and factory number 4. Now, imagine that all of these light bulbs are, sold out on the shops, and you have no way to figure out which one belongs to which factory. The problem is that you need to figure out that if you go out in the market and buy one of those bulbs randomly, what is your probability that the bulb that you have bought will last greater than 5,000 hours? Right? And what basically the total probability theorem tells you is that the probability that you'll get bulb from factory 1 multiplied by the probability that that bulb will last more than 5,000 hours plus the probability that you will get a bulb from factory 2 multiplied by the probability that the bulb of that factory will last more than 5 hours. And there are 2 other terms. If you multiply the 2 and you add all of them up, you get the probability that your randomly chosen bulb from your market will last more than 5,000 hours. This theorem is called total probability theorem. And we use this theorem to calculate the probability that our probability of exceedance of a certain PGA value is X, right? So remember the attenuation functions, right? Each one of those attenuation functions, what they did was they developed these attenuation functions as a function of magnitude. The larger the magnitude, the higher will be the line, right? So they segregated these attenuation functions as a function of magnitude. And then, we have a probability of your certain PGA being exceeded given by this shaded area, right? So basically when you multiply this probability with the probability of the magnitude M, right, which we have worked out from one of the Gutenberg-Richter, you have magnitude M and the probability of exceedance. Remember this line? Okay, so if you multiply this with this and then the distance from the fault, and you sum up all of this for one source, and then again sum up all of this for all of the sources, and I know I've skipped a lot of mathematics here, but this is, I need to do this because I need to move forward. So you get, at the end of the day, you get a number for each of these peak ground acceleration values. My, by the way, the ground motion of my choice is PGA here, right? So, and you can see that as my peak ground acceleration increases, this is, by the way, peak ground accelerations for, I think, Islamabad. Yes, Islamabad. They have worked it out for Islamabad. So this is real, guys. There are multiple sources, as you can see, the Jhelum fault, the main boundary thrust, the main mantle thrust, the Puran fault, and the rivet fault. There are multiple fault lines, around Islamabad. So they figured it out for each one of those sources. You remember source 1, source 2, source 3, source 4, and then they added up to get this solid line, which is our probability that our certain magnitude of PGA is exceeded. Basically, what I can tell you is there is absolutely no probability, perhaps a little bit of probability that my PGA will be exceeded by a magnitude of 1. This is PGA, by the way. This is not spectral acceleration that I'm talking about. But my probability that that my PGA will be exceeded above 0.5 is approximately 0.001 or 0.1%. So these curves are known as hazard curves, right? Right? These curves are known as hazard curves. And basically, what hazard curves give you is the probability of exceedance of a certain ground motion measure, PGA in this case. We then use these hazard curves to develop uniform hazard curves. Now, what are the uniform hazard curves? Do we like to take a break? Right? Okay, 10 minutes. But let me finish this. Remember, guys, we were working with PGAs, peak ground acceleration, no interest to a structural engineer. Even if I have this information, what good is that for you if you're designing a building, right? But I am interested, on the other hand, if I can develop the same sort of relationship for a single degree of freedom structure as a function of distance, I can develop my attenuation functions and then use those attenuation functions to generate these kind of curves where I have spectral acceleration. Now, this is 5% damped single degree of freedom system, right? On the x-axis, and along the y-axis, I have mean probability of exceedance. Now there are other variables involved. This is PGA curve, when my time period is equal to 0. But then I have 2 second, 1.1 second, 0.5 second, 0.2 second, and 2 seconds, right? This is my time period of the single degree of freedom oscillator. So I have a whole, range of those curves. And what I can do is I can then select a hazard of my choice. I can then select a level of acceptance of probability of my choice, draw a single line through it, and what I get is for a 0, I have a certain probability of a certain spectral value, right? So this is that. Then for 2 seconds, I have another spectral value. This is that. Then for 0.1 second, 0.5 second, 0.2 second, I have all of those spectral values over there, and I can then develop what is known as uniform hazard curve. What is a uniform hazard curve? A uniform hazard curve is a plot of spectral acceleration that has a uniform probability of exceedance. Do you understand what I'm saying? Any uniform probability of exceedance. I can select 1% probability of exceedance. I'll have one set of those. I can say 2% probability of exceedance. There will be another set of those, but of lower magnitude, right? most of the hard work done, guys. Now let me, after we come back from the break, I'll take you from this theoretical background to the latest codes as to what they're saying, because since 2010, since ASCE 710, they have shifted the design of the building. There has been a paramount shift in the philosophy of design. Previously, they did not follow the performance-based approach when they were writing the codes, but now they do, since ASCE 710, and that has resulted in significant increase in seismic loads, as you'll see. But in Pakistan, we are sitting, we are relying on a code that is more than 20 years old at this stage, right? So let's talk about that after we come back from the break. कैसे क्या कर रहे हैं?
सर मैं जॉब कर रहा हूँ एनवायरमेंटल सब्जेक्ट में।
अच्छा।
तो सर मेरी सऊदी में जॉब हुई है
कैसे आप जा गए? अच्छा,
तो वहाँ भी सर एज अ ड्रेनेज इंजीनियर।
कब जा रहे हो?
सर 10 डेज वीज़ा के लिए गया हुआ है सऊदी एम्बेसी के।
गुड यार, मतलब अल्लाह ताला खुश रखे। अल्लाह का शुक्र है। तो यहाँ पे एनवायरो में काम कर।
जी सर एनवायरमेंट।
अब आजकल आईडेप
आप लोग कहाँ काम कर रहे हो?
मैं तो लेक्चरर
वहाँ पे भी है उनका सिविल इंजीनियरिंग प्रोग्राम? नहीं तो उन्होंने खत्म ही कर दिया।
नहीं सर चलता है, डॉक्टर ला रहे थे आपके जाने के बाद।
हाँ,
फिर उन्होंने ये परसों किया, उन्होंने फिर परसों करने के बाद
कहाँ गए हैं फिलहाल? जी। तो आजकल कौन है?
आजकल सर वाइस चांसलर, प्रो वाइस चांसलर है अकरम चौधरी साहब।
अच्छा,
चौधरी अकरम साहब जो शायद आई थिंक नैब का भी केस चली, नैब की केस फाइल है।
अच्छा।
14-13 करोड़ देंगे वो आजकल इनके एज ए पार्टनर आए हैं, मुझे लगता है कि वो हेड आए हैं।
तो सिविल इंजीनियरिंग प्रोग्राम दोबारा शुरू कर रहे
ये
हैं?
सब चल रहा है अभी तक।
तो मैं इसमें तो बंद कर दिया था।
बंद कर दिया था, बीच में अलाउ किया। अब इनके एक्रेडिटेशन के बाद इनके 14 बैच हुआ है, 14 और 15 का। तो अब इन्होंने कहा कि आपको अलाउ है 16 का नहीं टेक अलाउ है। तो अभी अप्रूवल नहीं है 14 और 15 का, क्योंकि वो अलबानी वो जो है ना गवर्नर साहब ने साइन नहीं किए हुए।
अच्छा।
यूएल का केस सबके केस ऐसे हो गए।
यूनिवर्सिटी लाहौर के भी रुका हुआ?
गवर्नर साहब का फाइल गई थी, उन्होंने साइन सिग्नेचर नहीं किया था किसी के भी। इस यूएल के अलावा यूनिटी खाने वाला का भी केस भी सर सबके उसके साथ।
अच्छा, चलो अल्लाह ताला बेहतर करेगा यार। तो आप लोग कैंपस की तरफ तो राइविन रोड में तो इलेक्ट्रिकल भी चल रही है?
इलेक्ट्रिकल चल रही है, अगर इनटेक अलाउ है, अगर इनटेक इस पर आ गया तो ठीक, नहीं तो वो बंद करना है। फिर डिजाइनिंग भी करते हैं आप इवनिंग में कि बस आइडिया
नहीं, वो तो थोड़ा बहुत चलता ही रहता है जो भी है। अच्छा। तो फास्ट से कौन कौन है जी? आप हैं?
सर हम तीनों मेरे पास है
सर साहब का सब्जेक्ट पढ़ा था, मैं एडवांस डिजाइन
वहाँ पे सुना है? तो वहाँ से सुना है कोई नया बंदा है वहाँ पे हेड?
हेड आए हैं, डॉक्टर शाही साहब तो चेंज हो गए
चलेगा सर हमारे पास 14 to 16 बैच में थे। हम लोग चलेगा उसके बाद बाकी पता नहीं बाद।
अच्छा।
फेसबुक पे अनाउंस करना। For our audience on Facebook, we are right now having a temporary break of 5 minutes. Inshallah, we will resume at 4:45 p.m. Thank you.
कितने हैं सर?
15 के करीब। YouTube पे भी है ना, Facebook पे भी है।
YouTube पे कितने सर?
YouTube पे है कोई 8 के।
क्या हाल है? यूटी लाहौर? अच्छा।
मैंने सुना था कि आपका लेक्चर है, तो मैं पहुंचा वहाँ
तो
आगे।
कौन सा सेशन है आपका?
सर 1-3
अच्छा,
सर
आप लोगों को मैंने नहीं पढ़ाया मेरे ख्याल से। पढ़ाया?
मैटलैब पढ़ाई हुई है।
क्या आजकल फाइनल ईयर में आप लोग?
सर पास आउट हो गया, 1-7 में पास आउट हुआ था, तो जॉब कर रहा हूँ।
कहाँ पे?
बेमसो प्राइवेट लिमिटेड में जॉब कर रहा हूँ।
ये जो इनकी है अटक वालों की?
नहीं सर, अटक वालों की नहीं है।
नहीं, ये कोहाट सीमेंट वालों की है।
सीमेंट का।
वो कोहाट सीमेंट का काम आता रहता है आप लोगों के पास का?
सर वो बस आजकल भी उसी का चल रहा है।
क्या हाल है?
आजकल भी उसी का चल रहा है। कोहाट सीमेंट का 9-4 की रक्षा चल रही है, तो उस पे प्लानिंग है।
क्या? अच्छा, वो अपनी आजकल एक्सपेंशन कर रहे हैं। मेरे ख्याल से 2 साइलोज थे उनका, मेरे पास आया था बंदा आपके, 2 साइलोज हैं आपके, मुझे वो कर दें।
सर लाइन 4 की तो इरेक्शन ऑलरेडी चल रही है, एक्सपेंशन जो होनी थी उसी प्रोजेक्ट में, तो वो आई गेस 3 साइड और सीमेंट साइड।
आप लोगों के पास कोहाट की ज़्यादा काम होता है ना?
सर कोहाट का भी होता है। कोहाट तो हमारी एक सॉर्ट ऑफ पेरेंट कंपनी है, आप ये कह लें। बाकी भी ऑल ओवर द पाकिस्तान में आता रहता है।
प्रोजेक्ट्स कौन कौन से हैं? अच्छा,
सर रिसेंटली एक वो है, और दूसरा ओरिएंट मॉल का जो है वो उसके पीछे पड़े हुए हैं।
ओरिएंट स्क्वायर, ओरिएंट मॉल जो है वो तो हो गया वेट, उसको मैंने किया पिछले दिनों।
अच्छा,
वो डिज़ाइन हो गया?
नहीं सर डिज़ाइन तो हो गया, लेकिन कंस्ट्रक्शन के पॉइंट ऑफ
अच्छा 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 अच्छा, वो इजहार वाले भी पीछे हैं।
हाँ जी, इधर वाले भी पीछे हैं उसके। देखिए किसी में
अच्छा खासा पैसा उसमें, काफ़ी सरिया है।
सर और भी बहुत कुछ है, रीइंफोर्समेंट के अलावा सर ग्रेड में भी आपको पता है काफ़ी पैसा होता
तो लाहौर में रेडी मिक्स ही चल रही है।
है। सर लेकिन ये कि मोटे प्रोडक्टर्स होते हैं जिनका अपना कुछ प्लांट होता है।
हाँ, अगर रेडी मिक्स आप लोगों का अपने ख्याल से अपना है, बैम्सोल का है ना?
जी सर, तो वो फिर फायदा हो जाता है।
ऑफिस कहाँ पे है?
जसपाल हाउसिंग सोसाइटी फेज 2।
चतुर्थ ट्वेल्थ में आपने की थी पीएचडी?
12।
बेटा तो यूटी आई थी आपकी। तो मैटलैब आपने पढ़ाई
हाँ,
थी?
आप लोग अभी ग्रेजुएट कर, आप कहाँ काम कर रहे हैं?
यार हमारे जब फास्ट चले ना एमएससी
उधर
उधर से।
यूजी से क्यों नहीं की?
ये कम्युनिटी से
आप
चल
ये वहाँ पे मैंने शुरू की थी फास्ट में, वहाँ से।
आपने छोड़ के दूसरा से यूटी से फास्ट से लेके थे आप?
यार एजुकेशन इन पाकिस्तान इज क्लोज्ड एंडेड। आप वो किसी ने शेयर किया होता पिछले दिनों फेसबुक पे कि डॉक्टर बनने के पता नहीं कितने 22 साल करके तो दुआएं करके डॉक्टर बनाया, तो स्लाइडें पढ़ पढ़ के। दैट वाज ट्रू, दैट वाज,
एग्जैक्टली सर, ऐसे ही है।
वो किसी ने शेयर किया होता ना,
जी सर, ये होता
आई डोंट नो, मतलब वो आपको क्लास में रहेगा, मतलब आई वाज गोइंग थ्रू इट, आई लाफ्ड, सो दैट इज ट्रू।
एग्जैक्टली सर, ऐसे ही है। अभी भी ऐसे ही चल रहा है सर।
वो चेंज नहीं हो सकता।
स्विच कैसे कर लिया फास्ट में आपने यूटी से फास्ट? वहाँ पे
फास्ट
रही
मैं छोड़ दिया फास्ट को, मैंने रिजाइन कर दिया था यूईटी से।
अच्छा अच्छा।
हमें तो सर ड्यूरिंग सेमेस्टर छोड़ दिया
नहीं, मैं जनवरी में छोड़ के गया हूँ।
कंप्लीट करवा के गए थे।
जनवरी में आपका सेमेस्टर खत्म हो गया था।
अच्छा
जनवरी से खत्म
सर,
हुआ।
आपको कोई लेक्चर नहीं छोड़ेंगे, इसलिए याद है सर।
अभी उनको देखिए ना, जिन्होंने फाइनल ईयर में मुझसे स्ट्रक्चर इंजीनियरिंग पढ़ी थी।
जी जी, वो भी वो 1 के थे आई गेस।
हाँ, मैंने 1-2 और 1-3 को पढ़ाया हुआ ना।
1-2 को
1-2 वाज फर्स्ट। पता नहीं आपने मैटलैब यूज किया कि नहीं, मैंने तो किया काफी। उसके बाद
जी सर,
कहाँ, कहीं नहीं।
ये सर एप्लीकेशन के तौर पे यूज करने की बात कर रहे हैं।
तो करंटली कहाँ जॉब कर रहे हैं किस इंस्टीट्यूट?
मैं यार यूनिवर्सिटी में तो नहीं, मैं उधर आईडैप में हूँ।
बस अब टीचिंग से
सर बाहर आ गए। टीचिंग सर ने बहुत सारे इतनी जबरदस्त टीचिंग करते थे आप।
इस साल छोटी क्यों वैसे टीचिंग कोई ठीक ही जगह
टीचिंग यार क्लोज एंड जॉब है।
अच्छा अच्छा अच्छा, ओके ठीक है। We will resume the lecture now, and भाई वालों का आ जाए अंदर. So there was one announcement which I could not make during my introduction. After the lecture is completed by Dr. Saab, we will have a question answer session. You are free to ask any question, but related to the topic, one. And second, After the question answer session is completed regarding today's lecture, if you have any questions regarding PSCE, I would be here to answer them. Okay. Thank you, Dr. Sir.
Thank you, sir. So let me start off where I left earlier. So once we have the uniform hazard curve, we can do a lot of things. I'll come back to this, but let me show you what we do with this information. All of probabilistic seismic hazard analysis and deterministic seismic hazard analysis. How is all of that mathematics? How does that work for us? This is, basically on the left-hand side, you see a slide from the Pakistan Building Code, and on the right-hand side, I have produced a slide for you guys from a PhD thesis by Kim. Kim did his PhD from University of Illinois in Urbana-Champaign, and he has basically developed micro-zonation type of model for the northern Pakistan region. What he has done is he has identified individual fault lines, and then he has developed contours of exceedance of a certain PGA. So the slide on your right hand side shows a 0.8, then it shows a 0.6, 0.4, 0.2, and basically what is this? This is basically the contours showing you that probability of exceedance of 0.8 G. Probability of exceedance of 0.8 G with a return period of 2,475 years. This return period comes out to be 2% probability of exceedance, which is as per the latest codes. So this is very simplistic. This is perhaps closer to the reality. And imagine, what we're doing with this Pakistan Building Code to our buildings that are under construction. Then there is this map that was developed by the Global Seismic Hazard Initiative. It has USGS involved in it. Then it has the Swedes, the Europeans, and everything. What they've done is they have developed these contours for the whole world. And if you look at this, again, the PGAs are very different from what we expect the PGAs to be from the Pakistan Building Code. Some other literature identifying the sources of seismic hazard in Pakistan. This is one of the figures, and this is Chaman Fault. It's a strike slip fault. Basically, the Indian plate is moving north, I think northwest, and is subsiding under the Eurasian plate, right? So it's slipping in this direction. I think I have another slide. Yeah, it's slipping in the northeast direction. So with a Maillard, magnitude of 44 millimeters a year. This is a very concise way of showing you all of the history of major events along the main boundary thrust. There's this concept of seismic gaps. Basically, seismic gaps, what are the seismic gaps? Seismic gaps are, if you have two plates, these plates tend to release energy in certain increments. As you can see, we had some energy released everywhere except in this region and perhaps in that region, which means that we expect the next earthquakes to exist, to occur within this length or within that length of the MBT, right? This is basically a phenomena called seismic gap. So, Karachi magnified. This is Ornak-Nal fault. Karachi is located here. Then we have another fault south of Karachi, and Karachi is very seismically active. Everybody who's practiced with any credibility knows this, but not anyways. Again, you have this catalog of major events that have occurred in the northwestern Pakistan. You can see some as old as 1885, and the recent one of 2005. This helps us, see how cracks, how faults are releasing energy, and where probably the next earthquake will originate from. So a very brief, few slides about tectonic setting of Pakistan. So how do we codify all of this theory and all of the geological information? In the US, they start off with a council called Building Seismic Safety Council, BSSC. It's a very small group of experts who meet annually and who decide about as to what shortcomings are there and what are the rooms for improvement. And about after a year, if that committee considers all of the the proposals and they approve certain proposals, this then goes in is published as NIRAP reports. After about a year, the NIRAP guys then approve or or consider all of the proposals, and that goes to the American Society of Civil Engineers, ASC 7. The latest one is ASC 716. And that then, these stipulations that then get incorporated into the IBC with an average lag of 2 years. So this is the chronology of development of codal stipulations. This is how things happen in the US. Now, this is the latest code, guys. ASC 716. How do we quantify seismic risk in this? They have given you, you start off with, remember we went to the map of Pakistan and we chose a zone. Those zones do not exist anymore. They have developed contours for all of the US, mainland US, and all of the the other states. And basically, you can find those contours in ASC 716. You go and you particularly pick the position of your site and you interpolate between the two, and you develop. You get two numbers from these plots: the SS, the short spectral acceleration, which is at 0.2 second, and the S1, the spectral acceleration at 1 second. What are these values? These values are the spectral acceleration at 0.2 seconds and the spectral acceleration at 1 second, somewhere here. They have done it for the whole of the US. Okay, so you go there and you pick those SS and S1. Why do you pick them? Because you will use this information to construct response spectrum. Once you have done this, again you go to this table 20.31. You have the SPTN counts, or you have, which is this guy over here, or the latest trend is to conduct downhole bore surveys and calculate and measure the VS30. VS30 is the shear wave velocity, average of the shear wave velocity in the first 30-meter depth of the soil beneath your foundation level. And now there is some disagreement. Some people say beneath the existing ground level. I prefer to say beneath your raft or beneath your foundation level. Right. So you basically pick this number from the geotechnical. You have this number from the geotechnical investigation, and you pick a certain site soil classification. Now, what are these values, FA and FB? Here is the thing. Remember, I gave you I gave you a very short, brief introduction to attenuation functions. Those attenuation functions were developed for California. How valid are they for the subcontinent? Well, we don't have that much amount of seismometer array in Pakistan or in the subcontinent. So right now the trend is to assume the ergodic assumption. Basically what they are saying is whatever is valid for one region of the world is valid for everywhere. But that dissipation is in the bedrock level, not at the surface level. So basically, the Earth's crest, it's bedrock, and then there is deposit on top of that. What the attenuation functions would give you is the value of seismic parameters dissipation, the measure of dissipation of seismic parameter of choice in the bedrock, not at the surface level. So that means that all of the PGAs that I got are useless for me, but they have to be converted into my shaking at the surface level. These factors, FA and FB, are those factors that convert that PGA level to my site-specific PGAs. All right. So basically, I have the site class, which is this guy over here, right? Remember? And then I have these values, which I calculated from here, and I would go and pick one of those values up, right? And then I would have these two values, FA and FB, multiplied with SS and S1 to calculate SMS and SM1. This is modified short spectral acceleration and modified acceleration, spectral acceleration at 1 second. All right, so let me give you why we do this. And I have a very interesting simulation. Imagine we have two ships, right? And those ships are subjected to waves, just like earthquakes, right? There's a smaller ship and then there's a larger ship. Now, the smaller ship will, roll easily when the wavelength is smaller, but the larger ship will start rolling when the wavelength of the waves is much larger. The same is the case with buildings. If you have, this is the bedrock level, and this is the alluvium, right? This building is short, so its time period is very small. But this building is long; its time period is long. So if this building is located on bedrock, bad news. If this building is located on bedrock, no worries. If this building is located on soft strata, as was one of the Margla towers was, bad news. Why? Because the phenomena of resonance. This is how waves passing in the soil will affect those buildings. This wave will do nothing to this building. So this is why you get those numbers, FA and FV. They are basically empirical coefficients to scale your bedrock accelerations. All right, so this is that. Anyway, so now FA and FE explained, understood? Now, once I have my modified spectral accelerations at 0.2 second and 1 second, I have to convert the two of them to my design spectral accelerations at 0.2 second and 1 second. How do I do that? Simply multiply it with, and I'll quote it, fudge factors, 2/3, 0.66. Okay, so there's no justification for that, and I don't want to go into the details as to how those 2 or 3 coefficients appeared in the code. It turned out that engineers in California were not happy about using these modified values of spectral accelerations directly. They thought that they were doing well. Then there was a sort of a political settlement between one party and another party, and they ended up including these fudge factors of 2 or 3. So politics everywhere. Anyways, so at the end of the day, you get this response spectrum from ASE 716. This is different from UBC 97. And I'll compare the two. This is your TS. short term, SDS. Remember this SDS? How we got this SDS, right? And this is your 1 second. This is your SD1, and this is how things are tied up as empirically, sort of, for a response vector. Then, just like the UBC, there are tables for your acceptable types of lateral force resisting systems. Two significant changes. Number one, as per AC 716, if the height of your building is above 160 feet, you cannot use any type of shear wall alone. UBC AC 716 forces you to use this shear wall system with an SMRF, not with an IMRF. Again, this was not there in UBC 97. In UBC 97, you can have a shear wall lateral force resisting system, whether bearing shear wall or building frame system, and just design the system. All right. So number one change. Number two is, here they have introduced, and I'm sure there are other changes. So I've just used it for a year or two. They have started to allow a new type of system, a dual system, in which you have special reinforced concrete shear walls with IMRF. That was not permissible in UBC as far as I remember. All of the dual systems, had to be either SMRF, I think, because here they have dual system with special moment frames and dual system with intermediate moment frames. This was not available. This facility was not available in UBC 97. But remember, I found it the hard way around. The height limitations, not permitted 160 feet. Basically, they will force you to use a shear wall with an SMRF if your building is 160 feet or higher, and if you intend to use shear walls, which eventually I think you would be, right? So the two changes that I have noted, and I do not say that this is all that is. In UBC 97, you would do this. You would, if you wanted to calculate the inelastic displacement from the elastic displacement, you'd use 0.7 RS, no more. They make you use the CD factor, and they actually specify this CD right here with the omega and the R. So for each of those systems, you have a different CD value. You no longer use 0.7 R like this. Okay, then this is a big change. UBC V is equal to CV over TI over R into W. They have significantly changed this. Now you use V is equal to CSW, and CS is basically a coefficient that depends on time period. This was always inversely proportional to the time period. No more, right? There is no time period. It's not divided by time period within a certain range, but then it's linearly dependent on time period, and it's linearly and it's inversely proportional to the square of the time period. And this is a significant change. So another important change in UBC 97, you would always do, the importance factor is based on the occupancy category primarily. In AC 716, they have moved past that. They don't care about why you are constructing a building, but what they care about is your number of persons at risk. Now, this is a more rational approach, right? So basically, what you do is you pick the number of persons that So this number of persons at risk is not confined to the number of people who would be who would sort of lose their lives if the building collapses. It includes the number of people whose life will be adversely affected, even if they are not immediately injured, or even if they do not immediately lose their life due to collapse. Example is hospitals. If you have a hospital building, there are doctors and patients inside the hospital building. But if that hospital collapses, that is going to affect the lives or of all of the patients that use that facility. So you count those numbers up, right? So this is significant shift from the other one. Now, so basically you pick the risk category from this chart, and then you pick the importance factor, right? For earth seismic load it's different, for wind load it's different, and for ice it's different, for snow it's different. So this is 25% for seismic category 3, and most of the buildings, for the tall ones, fall into this category. So here you have 25% jump straight away in your base shear. Previously you used to use this, right? Because if we have a standard occupancy structure, because we were focusing on why the building was being constructed rather than how many lives will be lost if the building collapses. So things have moved on since 20 years. All right. Then importance factor, most important. Pakistan Building Code, 10% probability of exceedance in 50 years, which means if you adopt those values, which I absolutely have no faith in Pakistan Building Code, frankly. But even if you believe them, even if you adopt those spectral values, the response spectrum in Pakistan Building Code, there is a 10% probability that your ground motions will be exceeded in the next 50 years. But if you adopt ASCE 716, the probability of exceedance is only 2%. All right. So this is where the world is. This is the international standard for acceptability of design parameter as far as seismic design is concerned. We are living 20 years back in time. Again, another significant change. UBC 97. You use this to calculate the approximate time period. And if you want to go into details, which nobody uses this, right? Everybody uses this formula. Or the program calculated time period. ASCE 716 uses this as approximate time period. And then it puts a cap. It says that this value of approximate time period cannot be exceeded by a magnitude the fundamental time period shall not exceed the product of the coefficient of the upper limit or calculated period CU from table 12.81, which is this guy over here, and the approximate fundamental time period TA determined in accordance with 12.8.21. So basically you use this, and then you resort to your finite element code. Even if your finite element code is telling you that your fundamental time period is longer than this, it says you cannot multiply this CU with this guy over here and then force your finite element program to not to have a fundamental time period greater than this value, CUTA. Why? Why does the code say that? Because what they have discovered is our formulation of the building structures is erroneously flexible as compared to the actual structures. And this is from a study of a number of buildings in earthquake zones. So UBC 97, you can do anything about it. You can use any time period, but this guy over here, basically it limits the upper time period. What does that do indirectly? It ramps up your base shear. It disallows any decrease in your base shear. So I'll skip this slide. Now, here are some important slides, and I'll compare these slides with in the Indian slides also. And this slide makes me angry, because professionally, I think that that they have done this deliberately. UBC 97, on which Pakistan Building Code has been based. Islamabad Zone 4, Karachi Zone 4, Peshawar Zone 4, Lahore Zone 2A. Building Code of Pakistan, Islamabad Zone 2B, Karachi Zone 2B. I mean, which one of the experts knew about probabilistic seismic hazard analysis or deterministic seismic hazard analysis? Who conducted these analyses in Pakistan? No one. Right? And yet they had this map, that you see in front of you. And it actually makes me crazy. So the OBO code, which is, basically a supplement of the IBC 2015, basically resonates this view. It gives you the SS and S1 of Islamabad, Karachi, and it also gives you SS and S1 of Lahore, which is very different from the Pakistan Building Code. I don't have that over there, but I think as a last resort, let's compare to what they have done with, let's compare our codes with the Indian codes. And I did this very quickly last night. This is Lahore, right up there, Zone 2A, comfy. This is Amritsar over here, the same place. The Indians have put it in Zone 4, right? Zone 4. We have put it in Zone 2A. Now, the Indian zones are definitely different from the Pakistani zones, but I can tell you that the Indian zones vary from Zone 1 to Zone 5. Right? This is Zone 4. This is Lahore, up there, way up there, right? Yeah, the bulge. Right? And if you compare, these are the Indian provisions, by the way, that I've used. They have their own R value, and their own SA over G values, which they might have calculated using the PSHA or the discrete seismic hazard analysis, DSHA. And this is how the two compare. This one is Amritsar, this one is Lahore. So the Americans, and the arrogance is profound. The Americans are wrong, the Indians are wrong, but we are right. And who has done it? I actually, I don't know. I want to reserve my comment. Anyways, so this is Amritsar, this is Lahore. Everybody knows Amritsar is right across the border. Again, I think this is the International Building Code. This is how, for Islamabad, this is how the response spectrum looks like. The Building Code of Pakistan, this is how the response spectrum looks like. We have successfully bluffed ourselves to serve the needs of the construction industry. And it has put so many lives in danger. Anyways, this is how the base shear compares. This is the IBC with the OBO parameters. This is the Building Code of Pakistan, 1123 versus 2730. This is for a building that my team was working on. And by the way, I have a stellar team. Okay. We think outside the box. Again, I'll just skip through this, because basically what this is telling you, this slide is telling you, is most of the engineers, they use ETABS once, and they use the response spectrum analysis. And what they do is, with ETABS and response spectrum analysis, they compare they use it to calculate drifts, the story drifts. Well, understand one thing: when you're using response spectrum analysis, you lose the signs. So you need to be careful when you are calculating interstory drifts, because the different modes, they exist concurrently, and one mode will be doing this and the other mode will be going in the negative direction. And if you lose signs, then you are erroneously adding the absolute value of one mode to the absolute value of another mode. How many of you have gone back and looked at ETABS and have searched as to whether ETABS actually combines modes and then adds the effect up, or ETABS is just calculating the absolute? Anyways, since I'm short of time, these are some ground motion measures. We have the PGA. Basically, I have the acceleration, ground history. I pick the peak acceleration and I call it the PGA. Then I have the PGV. Basically, I can integrate this accelerogram and calculate, plot variation of velocity of the ground, and I can pick the maximum value, and this is called PGV. And the PGD is basically integrate the velocity, calculate the displacement, and get the maximum value. This is called PGD. And then if I am, and I use time history analysis, I discourage the use of response spectrum analysis, although my team is dragging its foot all the time, because response spectrum analysis is so easy. You just press one button and that's it, right? But anyways, so all of these parameters are very important to know if you are conducting time history analysis. Anyways, the most important component of a time history analysis is its frequency content, and the frequency content is measured by Fourier spectrum. So you look at the response spectrum, you look at the accelegrams of different events, and you basically use the Fourier, you calculate the Fourier spectrum of each of those accelegrams. You compare the Fourier spectrum with the natural time period of your building. If the two matches, you use, or basically not as simple as that, but basically if the two matches, then it's a good candidate for selection. So all of that, I'll skip this very closely. Everybody knows this. This is a way to measure another parameter of accelegrams, the duration of the accelerogram. It's called bracketed duration. We specify a maximum and a minimum, and the first time the maximum is exceeded or the minimum is exceeded, first time there's an excursion outside this bracket, you start the timer and you finish it when the last time you exceed this bracket. It's called bracketed duration. Anyways, this area's intensity with another parameter, and I'll skip all of this. I think I'll not be able to cover all of it, so I'll probably. I wanted to introduce a last thing here. I wanted to talk to you guys about performance-based engineering. You might have heard the word, but performance-based engineering, the crux of it is all codes are cookbooks. Forget the codes. What do I mean by that? Well, I mean no R values, no overstrength values, no CD values, no rows. Row is basically redundancy factor. You set all of them equal to 1. Even no phi values, and use not nominal values of the materials, use the expected strengths of the material. For example, if you specify a nominal strength of 4000 psi, you know that most probably the actual strength of your concrete on average will be around 4300 psi. Use 4300 psi. All right. So you do away with all of the codes. You evaluate your structure at 2 levels: the SLE, which is the service level event, Remember the 2/3 I told you about the fudge factor? You do away with that also. The SLE is an earthquake that has 50% probability of incidence in 30 years, or basically a return period of 43 years. This is the earthquake that your building is likely going to experience during its lifetime. No longer a fudge factor of 2/3. This means that if your building is located in Islamabad, your SLE will be very near to your MCER level. If your building is located in Lahore, your SLE will be significantly less as compared to your MCER level. So it basically affects your design in this way. So you carry out a linear elastic analysis at this level, and then at this level, which is I've written it wrong. This is 2,475 years, 2% probability of exceedance in 50 years. Okay, so this is just erroneously reproduced here, and you carry out the full nonlinear analysis here. What do I mean by nonlinear analysis? In ETABS, you have those nonlinear hinges, right? And once you have a axial fracture problem, once you have a curvature, increasing curvature, with the increasing curvature, you can plot the M values, or you can use a fiber model. So that is most realistic, more realistic, or by far more realistic as compared to linear elastic model. But that is the stage at which you are explicitly considering the reinforcement in your structural members. Otherwise, the design practice that we follow in Pakistan, you are designing for reinforcement, yet you have never considered the effect of reinforcement ever in your computer models. All right, so let me end up with last comment. I'll not go through the performance-based approach. The common practice in Pakistan is develop an ETABS model, develop a separate SAFE model. Right? Wrong. Why? Well, let me show you a comparison of the stresses in your raft. The first example that I'm going to show you is, here is a raft that was modeled with the superstructure for the same building. The maximum value of pressure under the raft is 3,644 kip foot per foot. This is the moment, right? And then minimum is 1644. Keep these values in your head. And this is basically another model. So raft is modeled integratedly with the superstructure. This is the result. This is another model where you have a SAFE model. Now the problem with this approach is, once you apply the loads on your SAFE model, it will deflect. But your superstructure, which was put on fixed supports, will never know the effect of those deflections. Right? And so basically you are overestimating axial forces and moments in some columns and underestimating axial forces and moments in other columns. How profound is the effect? 2,508 kip foot per foot and 1,670 kip foot per foot. Now, this is significantly different from this, but okay, so this might not have bothered you much. How about the effect on shear walls? I have this reinforcement in the shear wall, one of the shear walls. This is the integrated model, I guess, right? Raft. Yes, this is the integrated ETABS model, which means that the raft was modeled with the superstructure. You can see that my reinforcement here is 4.5%, 2.3%, 1.5%, right? If I move to the other model where my raft is increased, this is not 4.5%, this is 1.95%. So basically, we underestimated the forces, the moments, and the axial flexure in this shear wall had we modeled, superstructure separately from the substructure. Anyway, so this is it. I understand I couldn't cover all of the subject. I hope you have enjoyed this. And with this, if you have any questions, please let me know. Okay, no questions?
Question has any rules there?
By adopting a lower level of risk, such as 2% in 50 years, we are increasing the cost of our buildings. Is that correct?
Sir.
So the UBC and the Pakistan Building Code is a copy of the UBC, accepts a risk of 5% in 50 years. What would you suggest should be the risk for a country with limited resources such as Pakistan?
From the state of practice, sir, what I've seen is that whether we have used a lower probability of collapse, higher probability of collapse, we end up putting more reinforcement that is needed. Everybody knows it. So we need to see this opportunity as rationalization of putting our resources and rationalizing our insecurities about our designs. We can use UBC 97, but many of the reputed engineering consultancy firms in Pakistan end up putting way more reinforcement in the shear walls and little force resisting systems as compared to the needed or the required values. Number one. Number two is there's always a trade-off between safety and cost. We can construct buildings cheaper by putting lives at risk. And the real question is, what I always do is I sit with the client, I brief him about this, and then I ask him as to what he wants to do. Sometimes the clients are, they insist, no, we want the cheapest building that is legally possible for construction. But you'll be amazed that many of the clients would say, no, I want to do the right thing. And they end up paying more. But as structural engineers, I think it is fundamental that we should educate the client, number one. Number two is there's added cost to it. I would say that if the world has found it unsatisfactory to have this added risk at a cost discount, then we should also follow suit. People who have money is mostly government. In government, there are a lot of wastages. They don't bother about making the building more expensive. But on the other hand, private clients, sometimes they do insist to have a cheapest building. So I would say these things have to be forced upon to create a culture of safety. I don't foresee us constructing less buildings because of this increase in cost. But anyways, I mean, this is just an opinion of mine, and probably,
Any more questions? Please go ahead.
So this contour line, 08, can you apply that also to select where the best places are for locating your large dams?
Sometimes yes, many times no, because the location of large dams is more or less specified by the catchment area, the lake behind the dam, and other political and issues. So if we have an array of locations, then yes.
Any more questions? Urdu में कर लें, शायद होने की जरूरत नहीं या सवाल है तो जरूर करें.
Right?
I guess
That's it.
we are done with it. Thank you,
Thank
Doctor.
you, sir.
Thank you very much. Well done. Very informative technical lecture given by Dr. Saab. We are really privileged to hear so much of information. Thank you again. Before I proceed further, do you have any questions regarding Pakistan Society of Civil Engineers? I am here to answer them.
So how to register in for membership?
Well, there are two ways to register. One is you go online. All the instructions are given there. You can fill the form online. You have to attach your Pakistan Engineering Council card. Okay, copy of that. And do we need a national ID card? That also, okay? And send it back. Then huh? One photograph. And everything will come to Ms. Sadia. She's the administrator of PSCE. So then it will take about 2 to 3 weeks to process your application because the board has to approve your associateship. Okay. So within 2 to 3 weeks, you can get the answer. In case you have any difficulty, the telephone numbers of Ms. Sadia are given on the website. You can always contact her, okay, directly. And from here, you can also get the form now. You can take it. And once that is approved, you will have to deposit rupees 1,000. If you are an engineer, if you are a student, it would be 250.
So MSc students.
We need a PEC card. You get that card based on your undergrad, so that's okay for us. Any more questions?
I have a question for the young people.
Yes, sir.
When they come here, they don't ask any question, they don't participate. This is very discouraging.
Please, you give them a short speech. No, you should come and give them.
You talk. You address them.
हाँ जी बेटा, क्यों नहीं आप लोग बोलते हैं, शाये होते हो, क्या मसला है? आप लोग हमारा एसेट हो. मैं अब उर्दू में कर रहा हूँ. कोई लैंग्वेज बैरियर नहीं होना चाहिए. मुझे पता है हमारी जो यूनिवर्सिटीज का इस वक्त जो स्टैंडर्ड है, आपको बैरियर नहीं होना चाहिए. उर्दू में सवाल करें. आपको अंग्रेजी बोलते हुए आप शाये हैं तो उर्दू में करें. लेकिन ये बेटा आप लोगों के करियर के लिए बड़ा जरूरी है. इतने सारे लोगों में आप खड़े होके बोलें. ये इंजीनियर के लिए बड़ा जरूरी है. यहाँ पे अपना जी सर.
मैं ये कहना चाहता हूँ, आप यंग जैसे मेरा नाम खालिद बशीर है, ये जरूरी नहीं आप लेक्चर के बारे में ही करें. ये आपकी कम्युनिटी है, सीनियर्स बैठे हैं यहाँ कंपनियों के मालिक बैठे हैं. आप मेरा मतलब है कोई क्वेश्चन करें, जॉब के बारे में करें, फ्यूचर के बारे में करें, जो आपका दिल करता है. क्यों सर इजाज का
पीएससी जी, पीएससी जब मैं ये टाइम देता हूँ आपको पीएससी के बारे में, तो आप अपनी कोई जॉब की मुश्किल है वो पूछें, आप पीएससी के बारे में पूछें, आप इंटरेक्ट करें और खड़े होकर इंटरेक्ट लोगों को फेस करके. ये एक एजुकेशन है जो आपको यूनिवर्सिटी नहीं देती अनफॉर्चुनेटली. यू शुड हैव द कॉन्फिडेंस टू स्पीक अमंग सो मेनी, इन फ्रंट ऑफ सो मेनी पीपल. ये भी एक शाइनेस होती है, ये आपने उतारनी है. ये नहीं उतरेगी तो आप लोग करियर में ये आपकी एक शॉर्ट कमिंग हमेशा से रहेगी.
हौसला करें. सारे जॉब कर रहे हैं जॉब, तो क्या जॉब में कोई खड़ा हो गया?
अच्छा, लेट मी खालिद बशीर, लेट मी स्टार्ट जी. आप अपना इंट्रोडक्शन कराओ. सब एक बंदा इंट्रोडक्शन कराओ. लेट्स स्टार्ट विद इट. हाँ जी.
I've done my civil engineering from UT Lahore. I passed out in 2011 and currently I'm working in art construction as a manager planning and coordination.
माशाल्लाह जी. आओ बेटा.
Assalamu alaikum everyone. My name is Ahmed David Sir and I have done my engineering from UT Lahore from monthly session. And Sir Bhagwan Muzafar is one of our teacher. I'm a very big fan of him. And sir, thank you very much for today's lecture.
Sure.
And I'm working with Bensoul Private Limited as a planning and engineer.
Sure जी. माशाल्लाह. सर.
Sanjay, I'm from UT 9499 and working with art construction for the last 20 years.
माशाल्लाह. सर.
I'm Shahidul from 76 UT. I'm working my own with some private limited.
Thank you sir. खालिद साहब.
Khalid Bashir ji, 76 UT Lahore, or working with SMEC International Australia's company.
माशाल्लाह.
I'm from DAS. I'm currently working with IDA on various hospitals.
Nice.
So this lecture has been very insightful for me because my final year thesis was in the same probabilistic probability assessment of RC frame structures. So this gave me a very good insight and added on to the knowledge I already have. So it has been very useful for me.
I'm really happy to learn that this lecture has been the most
Yes,
beneficial for you.
It connected my
You are the real beneficiary of this lecture. That's nice. Yes, sir.
So you used it from UT or 2010 session, right now working with higher value quantity control.
Nice. Thank you.
Mr. Because the 2013 session from UT Lahore, I'm also student of yourself.
MashaAllah. Very good. Very
I'm
good.
currently working in UMD Lahore as lab engineer.
Nice. Sir,
Mohammed Usman, BSc from UT Lahore, MSc from Fast University and as a teacher in UMT.
Your subject in
Hydraulics.
hydraulics.
yes, sir.
Shakir Ahmed, BSc from UT Tesla, working as a lab engineer in UT Lahore.
MashaAllah.
Mohammed Shahrukh, I'm a structural engineer. I did my bachelor's from UT Lahore and master's from Polytechnic of Milano, Italy. And I'm working as a lecturer in UT Lahore.
MashaAllah. I am honored to introduce you, sir. You don't have to introduce yourself. I am honored to introduce you, Mr. Gerard. I remember you are from Netherlands.
The Netherlands, I've studied in Holland.
Okay. And now you are working in Pakistan with?
Team leader of Stream and Panchnath Barrage Rehabilitation.
Thank you, sir.
SMEC.
We are honored to have you here, sir.
Thank you for a very good lecture.
Janab, sir.
My name is Abu Bakr. I am graduated from UT Texla, the second session, and I am a site engineer at NSC. So,
Nice. Yes, sir.
So I got graduated from Fast University and currently working in DH as associate professor.
MashaAllah.
So I have a question on
Go ahead.
SC. Sir, I not much familiar with SC. I get first lecture. So if I get membership, so what outcomes I get after getting membership? So what are the benefits?
Okay. Okay.
And give me some background of APS.
Once we finish it, then I'll give you the answer. Ridwan,
And, sir, another question from sir. Sir, I am recently graduated. So this is the only thing which is different from state of the art, seismic design. So other factors are there, like wind, live loads, wind loads. These are studied in the RPSC study. So you only target the seismic design. So I have in mind that you are cover all the other aspects like we have design and we have execute in the field. So the difference in the field and from our country and other countries, these should also be discussed in my point of view. So you only restricting the design purposes. So I must ask you the other things.
I think better answer him first, then I'll continue.
So the short answer to your question is I only had 2 hours and I had to skip a good part of my lecture, which I was more interested in introducing to you guys to, which is performance-based engineering. And my forte is design. I'm sure that there are other people who are better equipped with execution of the project. So I could only speak about what I know, and I don't know everything. So,
I said other than seismic design, so there are many.
When, yeah, I know. I couldn't touch those topics because I had picked the most critical one. And if you look at the design of even the, not the very tall buildings, even the moderately high buildings, they are mostly affected or controlled by the controlling factor is the seismic load, not the wind load. Although at service limit state, there are issues that we need to address. But you're right, I mean, I couldn't touch the rest of the topics, perhaps some other time.
फिर बुलाएंगे डॉक्टर साहब को. Let me introduce the 2 gentlemen here. Both of them are my class fellows. Ridwan Mirza, he is a graduate of 1980 from UET Lahore, and he's practicing since almost then. I think worked for NASPAC for about 2-3 years. Then he started his own practice, and one of the most experienced structure engineer in Pakistan and in Lahore. Azhar Ali Bhatti, again, we are of the same batch, graduate of 1980, civil engineer, UET Lahore, and he has been working since then with various companies. He has been working in Switzerland also, and a very experienced engineer, especially for the steel structures and concrete also. And now he's working for either design manager or general manager with Izhar Construction, huh?
He's a director.
Director. I'm sorry, Ji. I'm sorry. I beg your pardon. Director, and mashallah, both of them are very respected engineers, civil engineers in Pakistan, highly respected. After all the time.
My name is Naseem Khan. I have done my civil engineering from Texas from 2010 to 2014. Currently, I am doing MSc Construction Management from UT.
Hafiz Salat, and graduated from 2014 from UT Lahore. Did 3-year job at Saudi Arabia and now came back. Did 1-year job there and now started MSc in Construction Management.
Where were you working in Saudi Arabia?
Riyadh.
Yeah, with which company?
Yeah, Paradise.
And how was your experience there?
Yeah, good one.
Good one.
Yeah.
Next.
Sato Yusuf graduated in 2019 from Gutenberg-Richter and now I'm doing MSc Construction Management from
UT Law. Thank you, Sakib sir. Ji.
Amanat Ali, I have done BSc Civil Engineering from UT Texas. Currently, I am doing my master in construction management from UT Law.
Good. Janab.
Mohammed Salman Iqbal studied from University of South Asia, passed out in 2012, and did my MSc from FAST University in 2016. Working in Enviro Consultant as a resident engineer now since last 6 years. And my feelings are same as Sir elaborated the difference between design. I am working as a resident engineer on public health engineering projects like WASA and public health department. There are many flaws and blunders in design as well. On-site execution, when we are laying some civil system, if minimum size, for example, is 12 inches, but on-site it's not enough. Recently I designed for UC 91 and 71 Islampura subdivision for Wasa Lahore. There, the people of these areas putting their garbage and other material for this system was chalk. So this is uneconomical. They change it into 24-inch diameter. As design concerned, software concerned, this is absolutely right. But as per site, there is 100% different. As sir concerned, just क्योंकि वहाँ पे भी डिजाइन में इतना चेंज है और यहाँ पे डिजाइनिंग की वैल्यूज इतनी ज़्यादा डिफरेंट हैं और ये बस सिस्टम का
ठीक है. Very nice talk. I'm really encouraged. हाँ जी, आगे चलें.
Usman Iftakhar, I have done my graduation from UT Lahore in 2018. Now I am doing the MSc in Hydraulics Engineering from the same university and working as a research assistant in the Civil Engineering Department at UT Lahore.
Nice.
My name is Asad. I did my bachelor's from University of South Asia. My batch was 2013, and I did my master from Fast University Lahore. I am a student of Sir Fawad and working as a lecturer in University of South Asia.
My name is Muhammad Aslan Khan. I did my graduation from University of South Asia. Now also I did my MSc Structures in Fast. I'm also student of Sir Fawad. I'm working as a lecturer, MSc lecturer in University of South Asia.
मीरा साहब, आप कुछ कहना चाहेंगे? बच्चों को कोई एडवाइस देना चाहेंगे कि करियर पे इनकी, कि मैं कुछ कह के तो हम सर्टिफिकेट देते हैं? वैसे ही इन जनरल मैं कह रहा हूँ, कुछ फरमाना चाहेंगे? आप सारे एक्सपीरियंस.
What is the benefit of coming here? I would say that the first and foremost benefit is to know each other, to learn from each other, and by just being there, we can be of assistance to others. Other than what we do here, such as lecturing, we can exchange numbers and feel part of the same community. I think this is the biggest thing. And we can learn from the success that everyone has, and also learn from the failures that we have done. And we should not be shy of sharing them. Especially with the older people, we have a lot to learn from. I think we should not be shy of sharing. That is the foremost advantage of an organization like this. which is apolitical, purely apolitical. You will very rarely find a professional body in Pakistan which is not polluted by politics. Thank you very much.
I forgot to mention that both Rizwan and others are the founder members of the society, and their contribution is immense to the point where we have reached today. Now, you asked for the benefits of the society, Ji. One benefit is this, that you can attend the lecture. Then, as I have said in my opening remarks, that we have a quarterly magazine and a fortnightly newsletter, which is issued by our editorial board. And in charge of the editorial board is Rizwan Mirza. If you want to contribute, any one of you, you can contact Mr. Rizwan Mirza. And I would encourage you to come forward and contribute in our magazine and in our newsletter. It could be anything what you regarding civil engineering, you can contribute. Now, this is that, as I told you, that we started officially in January this year. Now we have consolidated our position vis-a-vis these lectures, technical lectures are concerned. We are having them regularly, once a month, and Alhamdulillah, up to December, we have already scheduled our lectures in advance. So this is our consolidation. Now the committees are being formed. You people can become the member of committees. As you people have been talking, what Dr. Saab has said, we have a lot of shortcomings. We have a lot of problems in engineering in Pakistan. You can come up with some research work. You can come up, if you want to do something, come on, tell us, and we will help you. We will sort out your problems and how to, sort out the problem and how to let other engineers know what you people are thinking and the solutions, the solutions of the problem which you have. So progressively, inshallah, more benefits will come in the society. At the moment, we have also problem of the funds. We have to guard our impartiality. That is a thing. If we start taking funds from every company or every organization, then our impartiality comes in question. We have to maintain that also. So, inshallah, I think as a chief executive of the society, I foresee that within 1 year, we will be, inshallah, quite ahead of many other societies who are working in Pakistan. Most of them are, as it is once said, polluted with politics. This is also one of our problem. We are learning from the experiences of other societies and other similar organizations, why they indulge into the politics. They were formed for a certain purpose, and they drifted from their purpose, and they started doing something which was questionable or which was not acceptable for the organizations like us. Okay? So if there is any other question, please let me know. Otherwise, I'll proceed with the certificates. आओ जी मेरा साथ उसी दियो आज नहीं आ जाओ मैंने आ जाओ मेरे साथ ऐसा नहीं
Muhammad Salman Iqbal. Mr. Ahmad Naveed Zafar. Mr. Muhammad Usman. Thank you. Mr. Muhammad Mohsen Waqas. Mr. Hassan Akbar. Mr. Wasim Khan. Thank you. Mr. Hafiz Talat Mahmood. Mr. Abdullah. Thank you. Mr. Shakir Ahmad. Mr. Usman Iftikhar. Thank you. Mr. Ahmad Husnain. You there? Okay. Mr. Shahid Akib. Mr. Amanat Ali. Thank you. Mr. Khalid Bashir. Thank you, sir. Mr. Tayyab Yusuf. Thank you. Tayyab Yusuf. Okay. Mr. Sakib Yusuf. All right. इसका नाम पूरा सुने. Mr. Gohar Ayub Ishaq. Not there. Mr. Gulrez Khan. You are collecting all the certificates.
All are colleagues.
Mr. Gerald Pitcher. Thank you, sir.
How many certificates you collected in Pakistan? Mr. Bishop, how many certificates
Mr.
you
Muhammad
collected?
Shahrukh Khan. Thank you. Mr. Muhammad Arsalan Khan. Thank you. Mr. Abu Bakr. Thank you.
Thank you. Now we will present a shield to our guest speaker. Who could be the person? Azhar, आ जाओ जी. Shield आप दें guest speaker को. आ जाओ.
Thanks a lot. Thanks a lot.
थैंक यू डॉक्टर साहब. सिर्फ हमारे यंग लोग ही नहीं शाय होते, हमारे सीनियर लोग भी शाय होते हैं. एंड अदर इज वन ऑफ देम. हैं जी. So we have now come to the end of this technical lecture. This last thing which I wanted to advise all the young engineers we were discussing in my room, and that is what is my experience. My son is also studying civil engineering in LUMS, and which is now rated to be, has a good rating in Pakistan. But still, this is my observation after conducting a lot of interviews with the young engineers, that in our universities, I am only talking about engineering universities, the books of engineering have been forgotten. The teachers have made it very convenient to give the notes in the class or the presentations on slides and teach them through the notes. And this is one of the foremost reasons why our education standard has gone down. So I would request every young engineer here that buy a book for yourself, and make it a habit to read the books. Books are written to be read. If you will read the books and you will try to solve your problems yourself by reading the book, nothing will compare to that knowledge that you will get yourself, you will extract it yourself. So my advice would be start reading at least the engineering books. Thank you very much. So now, sir, we can have a cup of tea. And